Bismillahirrahmanirrahim. Welcome to the quantity survey course. In this lecture, we will discuss the how to calculate the bar bending schedule of two-way slab. Bar bending schedule of two-way slab. So this is slab in front of us. It's two-way slab. To find how whether this is two-way slab or one-way slab, we have the formula. Divide the longer span by the shorter span. Let's we do it on the calculator to check whether our slab is two-way or one-way. Here you will see our longer span is 6000 and shorter span is 4000 divided by 4000. So our value is 1.5. Value is 1.5. Whenever longer to shorter span ratio is less than 2, it means the slab is two-way slab. That slab will be designed as two-way slab. So let's move for the calculation. Here I want to show you these alternative bent bars are provided at the means shorter side, and on the longer side these same alternative bars are provided. Both sides bar having 12 millimeter dia. Spacing between the bars is 150 millimeter center to center, and for same for the distribution bars having the same dia of 12 millimeter and 150 millimeter spacing from center to center. So on the both side are the same bars dia. Here beams are provided on the all the sides. You can see in the dotted line these beams are provided on the all side of the two-way slab. In two-way slab we provide beams in all the side because to negotiate the bending moment from all the sides. But in one-way slab we just provide the two beams on the shorter side, but on the in two-way slab we provide beams on the all the side because movement is producing on all the sides, on the shorter span and on the longer span. So here we cut the section. I will show you section here. This is the, bear in mind that this is the clear span. From clear span, longer clear span is 6000 millimeter and shorter clear span means the concrete cover is not included in it. It's clear span inner side. Okay, 4000 millimeter and 6000 millimeter. Let me show you the section of this slab. In the section you can see this is, here we cut the section. This is the section we cut it, and here you can see this is the one bent up bar bending here at 45 degree, then going straight, then other bar is bending from this side and other side is straight. This is called alternative bent up bars. So here bend length formula we have for this and for this same formula 0.42 h, and their bend length of this bend and this bend will be same because the depth is same. So to calculate this height, to calculate this bend length we multiply 0.42 with this height from the center of this bend length bar to the center of this bar. This is the h value. Okay, this is center. That's why we deduct from the depth, which is 150 millimeter, to concrete cover from top and bottom to calculate h, and minus 2 half of dia bar, because half of dia bar from this side, this bar, half dia from this bar, to go from center to center to calculate h. So this was the section. Now let's move to the calculate the number of main bars, distribution bar, and the top extra bar. Here you can see these are the in the yellow color you can see these are the top extra bar provided after the bends. At after the bend of 45 degree, these top extra bars provided. So let me calculate the first number of bars of main bar, distribution bar and top extra bar. Then we will calculate the cutting length of main bar, distribution bar and top extra bars. Finally we will calculate them their weights. So size of the slab 6000 by 4000 millimeter, thickness of slab 150 millimeter, main bar dia 12 millimeter, 150 millimeter center to center spacing, distribution bar 12 millimeter dia and the 150 millimeter center to center spacing, top extra bar having dia 8 millimeter and 150 millimeter center to center spacing, clear cover from all sides is 25 millimeter. Calculation will be in two steps: calculation of numbers of bar and cutting length of number bar, and finally we will calculate their weights in kg. Let me now start our topic. Here calculation of number of bar. First we will calculate number of main bar. There, this is the main formula to calculate number of bar. Total length minus clear cover divided by center to center spacing plus 1. But here we do not need to subtract the clear cover because we have clear span length. To calculate the number of main bars are provided at the shorter side. You can see here in the plan view. Number of bars, main bar are provided on the shorter side. So to calculate their numbers, we take the opposite length. So opposite clear span length. So opposite clear span length is 6000 millimeter. So to calculate number of main bar, 6000 divided by 150 millimeter center to center spacing plus 1. Let me now calculate it on the calculator. 6000 divided by 150 center to center spacing plus 1, 41. So 41 main bar number, 41 number of main bar required, and number of distribution bar, let me calculate on the calculator. 4000 divided by 150 center to center spacing plus 1, this is 26.66 plus 1, 27.66, mean 28 numbers of distribution bar required. 28. So let me calculate now the number of top extra bars on main bar side. On main bar side, to calculate the length required for the number of top extra bars, we have the formula L by 5. L here is the clear span length. We will calculate the top extra bar on the main bar side. So we will take the main bars are provided on the shorter span side. So we will take the longer span. Longer span is here 6000 millimeter divided by 5. Let me calculate now. 6000 divided by 5, 1200. It means we have 1200 millimeter length to provide the top extra bar on the main bar side. Here on main bar side, length required 1200. To calculate now number of extra bar, this we calculated the length on which we will provide the top extra bar. Here I will show you in the section view. We just calculated this length to provide the main bar or top extra bar on the main bar side, on this side, here. Okay, we are just calculating at one bend. So then we will multiply with the 2 to calculate the on the both side. Let me know 1200 divided by 150 plus 1. Let me calculate now on calculator. 1200 divided by 158 plus 1 9. We have 9 number of bars, 9. Then multiply the number of bar we have at one side bend with the 2 to calculate the number of top extra bars on the two side, which will be 18 numbers of bar along the main bar side. So now let we calculate the top extra bar on the distribution bar side. 4000 on the distribution side. Distribution bars are provided on the longer span, so we will calculate the take the opposite length, so which is the shorter span length 4000. So divide 4000 by 5, give us 800. Then 800 here, you can see 800. Now let me calculate the number of bars. These are the number of top extra bars. 800 divided by 150, 5.33 plus 1, 6.33. We take it 7. Then along both sides, both bends, it will be 7 into 2, 14 number of bar required on two bends. So finally we will calculate the number of main bars, distribution bars and top extra bars on the both side. On the both side we calculated. Let's move further. Now we will calculate the cutting length of all type of bar. First, main bar. Here formula to calculate the cutting length, we have clear span length. It's mean we already have clear span length, so no need to deduct clear cover. Plus 2 LD development length, 1 into 0.42 H bend length. I will show you in the section bend length at 45 degree. This is the formula to calculate bend length. And we have in one bar we have one bend length, that's why multiply 1 here. 2 into 1D. In one bend length we have 245 degree bend, that's why we deduct 2 into 1D. 45 degree formula is 1D. So 2 bends 45 degrees, that's why multiply 2. I want to show you in the section. In the section you can see this is the bend length provided in the one main bar. You can see this is the only one bend, other side is straight. So here this bend length formula is 0.42 H, and here height value put in it to calculate this bend length. So first we will calculate the H value. H value will be calculated by, here in the section you can see H value. Top we will deduct, depth is 150 millimeter, so we will deduct top and bottom cover, and then minus 2 into half dia of bar, and dia of bar of this bar is 12 millimeter, so minus 2 into half dia of bar. Depth minus 2 clear cover from top and bottom, minus 2 half of dia of bar, because we go from center of this bar to center to calculate this H. Here we calculated the H value. You can see H value 150 minus 2 clear cover from top bottom minus 2 into half dia bar. Half will be 6. 12 we have 12 millimeter dia bar, half will be 6. So H value is 88 millimeter. Cutting length of main bar will be, here you can see we just put the values in it. Clear span length on the of main bar we have 4000 plus 2 into bend development length L. Formula is 40D and 40, because we have both side development length, that's why multiply with the 2. 40 into D dia bar is 12 millimeter, plus this we have one band length. So this is the formula band length, 0.42 H value is 88, we put it, and we have one band length in one bar, so that's why multiply with the 1, and in one band length we have two 45-degree bends, that's why we deduct the two bands, 2 into 1d. 1d is the dia, 12 millimeter. So finally let me calculate it, the cutting length of a main bar, 4000 plus. So after calculating it, we have the 4970. Let me take it 72 instead of 73. 4973. 4973 millimeter. So convert it into meter. Just divide it by 1000. 4.973 meter is the one main bar cutting length, 4.973. So total number of main bar, to calculate the total cutting length of main bars, we will just multiply the number of main bar with the one cutting length, and one cutting length we have just calculated it, it is 4.973, and number of main bars are, here you can see number of main bars are, we calculated 41. So just here we will multiply the one cutting length with the number of main bars. This will give us the total cutting length. So 4.973, one cutting length of main bar, then multiply with the total number of main bar, 41. Total cutting length required for main bar is 203.8. Let me take it 204 meter. 204 meter total required cutting length for main bars. Let me calculate its weight. We have the dia 12, so here just put the length and let me calculate it on calculator now. 12 square, 12 is the dia in millimeter of the main bar, then divide it by 162, then multiply with the length of the total cutting length of the main bar, 204 meter. So 181.33, let me take it 182 kg weight required for the main bars. Now let's we move to the distribution bar. Distribution bar formula is same, here you can see, because the distribution bars are also having one bar having one band length and two 45-degree bends. So same formula, let me finally calculate it. We just put the values here, but here you can see clear span is changing. Clear span in the distribution bar on the longer side we have 6000 millimeters. So let me calculate now finally on the calculator. 6000 plus 960, then plus 36.96 minus 24. 6972, let me take it 6973. 6973 millimeter. Just divide it by 1000 to convert it into meter. 6.973 meter. So this is the one distribution bar cutting length. Let me calculate total cutting length of the distribution bar. So first we just multiply the number of bar with one bar cutting length of distribution bar. So distribution bar number we have 28. We have 28 number of distribution bar. Multiply the 28 number of bars with one cutting length. We have 6.973. Let me calculate it on the calculator. 28 number of bar into 6.973, so 195.24. Let me take it 196 meter. 196 meter total cutting length required for distribution bar. Let we calculate the weight of the distribution bars. Just multiply with the length in the formula here, 196. Let me calculate it on the calculator. 12 dia bar square divided by 162 formula, then multiply with the length, total cutting length of distribution bar, 196, 174. Let me take it 175 kg. For the distribution bar weight we require 175 kg. Top extra bar on both sides. Top extra bars on the main bar side on charter span. On main bar side, cutting length 1 bar. For 1 bar cutting length will be clear span plus 2 development length. These bars are straight bars, so no need to calculate the bend, deduct bend length, uh, add the bend length and deduction of the bends. So no need, just it's simple to calculate its cutting length. On the shorter side, clear span length we have 4000 because we are top extra bar on the main bar side. So calculating 4000 plus 2 into 40, 80. Let me take 8 into 40 plus 2, 640 plus 4000, 406, 4640, 4640 millimeter is the cutting length of one top extra bar. So to convert it into meter, just divide it by 1000. 4.640 meter is the cutting length of one main bar on the shorter span, main on the, along the main bar side, top extra bar. So let me calculate the number of top extra bars. So to calculate the total cutting length, this is the one bar cutting length of the top extra bar on the shorter span. To calculate the total cutting length required on the shorter span of the top extra bars, we will just multiply the one with cutting length with the total number of top extra bars on the shorter side. On the shorter side we have total number of top extra bars here. On the shorter side we have 18 and on the longer span side we have 14. So first we will calculate the cutting length of shorter span side. 18, just multiply 18 number of bar with the one cutting length, 4.640. So 4.640 into 18 we will give us 83.52. Let me take it 84 meter. 84 meter is the length required, total length required for top extra bar on the main bar side, on the shorter span side. So now we calculate on the longer span side, extra bars length on the longer span side. So it is 6640, 6640 millimeter, and in meter it will be 6.640 meter. So to calculate the total cutting length of the top extra bar on the distribution bar side, on the longer span side, we will just multiply it with the number of bar, and we know that number of bar on the shorter side, top extra bars are 14 number of bars. We calculated at the start, so just multiply with the one cutting length of the bar, 46.40 with the total number of bars on the distribution side 14. So let me calculate it. 14 into 6.640, 92.96, 93. Let me take 93 meter is the total cutting length required on of the top extra bars on the distribution bar side. So 84 plus 93, total cutting length of the extra bars. So total length, cutting length required for top extra bar on the both sides, we required 84 plus 93, 177 meter. 177 meter. Now let me calculate the weight of these extra bars. Total cutting length we have 177 meter, and just multiply with the length in the formula 177, and if we know that the dia of the top extra bar is 8 millimeter, so let me calculate it now. 8 square divided by 162 into 177, 69.92 means 70 kg. Let me take it. 70 kg is the weight of top extra bars required. Now we will finally calculate the total weight of the steel required for all bars. For main bar we have 182 kg, 182 kg. For distribution bar we have 175, and for the 182, 175 for the distribution bar, for main bar 182, and for the top extra bar 70 kg weight required. So total will be, let me calculate it on the calculator. 182 plus 175 plus 70, total weight we required of the steel for this two-way slab 472 kg. 472 kg. Thanks for watching this lecture. Please stay tuned for next. I hope this is clear.